Hey AP Stats, we are going to do the first couple pages of the chapter 3 notes, which is kind of an intro onto scatter plots and using two uh, data sets versus what we've talked about so far has just been one. So chapter 3 focuses on quantitative variables. Okay, so numeric. And we're examining relationships among variables. We want to look to see if one of our variables helps explain or even causes changes in the other variables. Response variable. Okay, so we're going to have two. The response variable and explanatory variable. Okay. Do you guys remember this from hopefully like Algebra 1, Algebra 2? We're talking about an X and a Y. The response variable. Do we know what that one is? The response variable is the Y. Explanatory variable is the X. Okay, so the response variable measures an outcome of a study. It's also known as the dependent variable because Y depends on what X is. X is the explanatory variable. It helps explain or influence changes in a response variable. So if the Y is called the dependent, the explanatory variable is called the independent variable. Okay, so you can think about back to like when you were solving equations, a lot of times you'd plug in an X and figure out what Y is. So Y depends on what X is. Okay, so in the next examples, I want you to identify the explanatory and response variables. So one of the early studies of the relationship between smoking and lung cancer was conducted by Hammond and Horn. They had an extensive set of volunteers and tracked 187,766 men over a 44-month period, noting their smoking habits and whether or not they died of lung cancer. Okay, so the two things that we're looking at, we know they're all men, but we're noting their smoking habits and then whether or not they died of lung cancer. So which one is going to be the explanatory variable? Okay, so it's going to be their smoking habits is going to help explain whether or not they died of lung cancer. Okay, I have a lot to say about smoking and all of this because that was something I worked on, tobacco cases when I worked before. So we'll talk about that in class. All right, example 2. In 2006, nurse Kristen Gilbert was accused of murdering hospital patients. Hospital records show that of 257 8-hour shifts on which Gilbert worked, a patient died on 40 of those shifts. But on 1,384 8-hour shifts to which Gilbert did not work, a patient died on only 34 of those. Okay, so what is going to explain? Sometimes it's easier to find the response variable. What are we trying to explain? We're trying to explain patients who died or patient deaths. And what are they trying to use to explain whether patients are dying? It's whether she was working. So whether Gilbert was working. Okay, so yes, this is real data. This is not something I made up. But are there anything else that could explain why so many patients died on her shifts versus nobody else's shifts, or the other shifts where she wasn't working? There's like a couple things that you could think of. Okay, so first of all, if she works in part of the hospital that's like an intensive care unit or like a cardiac intensive care, something where you have high-risk patients to begin with, then they're obviously more likely to have more deaths if something is more catastrophic. And then also something that you may or may not have known, there's actually typically hospital patients die more often at night. So if she's working the night shift in somewhere that's like the cardiac care unit, intensive care, both of those combined could help to explain why there are so many more deaths on her shift than other shifts. Okay, number 3. Researchers studied 15,500 healthy middle-aged adults, asking them to complete extensive surveys detailing their physical activities and their weight gain or loss between the ages of 45 and 55. They found that those who practiced yoga had substantially lower weight gain than those who did not practice yoga. Okay, so what are we trying to explain? The weight gain is what we're trying to explain. Gain or loss, I guess, weight change. And what is explaining that? Whether they participated in yoga. All right, number 4. Jim wants to know how the mean 2005 SAT math and verbal scores in the 50 states are related to each other. He doesn't think either score explains or causes the other. Jim has 2 related variables, and neither is considered the explanatory variable. Julie looks at some data and asks, can I predict a state's mean math score if I know the mean verbal score? So Julie is treating the verbal score as the explanatory variable and the math score as the response variable. And so in this case, since there isn't one that's specifically an explanatory versus a response variable, you can just choose one of them and still look at the relationship and how they're related. Okay? So calling one variable the explanatory variable and the other the response doesn't necessarily mean that changes in one cause, capitals, cause changes in the other. So we can say there's a relationship between 2 variables, but when you say that something causes change in the other, that's very specific, so you have to watch out for that. We're going to talk about that this chapter. So strategies for chapter 3 include, we're going to be plotting the data. Okay. And then compute numerical summaries. We're going to look for the overall pattern in our data and any deviations from those patterns. And really what we want to be seeing is a linear pattern is what we're going to be talking about this chapter. And then when the overall pattern is quite regular, so it follows a good linear pattern, and we'll talk about other nonlinear patterns, but we're going to use a compact mathematical model to describe it. So we're going to be able to fit a line to our data. Okay, so specifically we're going to be talking about scatter plots, and we're going to start off with correlation. So scatter plots is like just, you graph those a ton. It's just graphing an x and a y, and you're graphing the coordinates. Okay, so you definitely graph these. A scatter plot shows the relationship between 2 quantitative variables measured on the same individuals. The values of one variable appear on the horizontal axis, and the values of the other appear on the vertical axis. All right, so the most effective way to display the relationship between 2 quantitative variables is a scatter plot. Okay, a couple tips for creating a scatter plot. We're going to plot the explanatory variable, so our x variable on the x-axis. Okay. If there's no explanatory response distinction, either variable can go on the horizontal axis. So that was like with the SAT, math and verbal. You can pick either one to go on the x. We're going to plot the response variable on the vertical axis. That's usually denoted by y. You want to label both axes. And then you're going to use a scale. So if you're just keep counting by fives or counting by twos, whatever you're going to count by, just make it so that the intervals are uniform. And for a scatter plot, we want to try to use a scale so that our plot uses the whole grid. We're going to be looking at the relationship between the two variables. So it's important to emphasize if there's a linear relationship, a curvature to it. So we really want our graph to take up the whole grid. Okay, so here's an example of that. The report titled 2005 College Bound Seniors included the following table showing the average score on the verbal section of the SAT for groups of high school seniors completing different number of years of study in 6 core academic subjects. So art and music, English, foreign language, math, natural sciences, social sciences, and history. Okay, so the number of years of study means like, oh, if you have 4 years of math and 4 years of English, and you're going to add up all those to get your total number of years of study for all those courses. So do you notice a trend? Okay, so as the number of years of study go up, what happens to the average verbal SAT score? We're going to see it also goes up. But we don't necessarily know if that's linear or if it's following some other pattern without graphing it. Okay, so first off, what are the explanatory and response variables? Here, the explanatory and then the response. So what is going to explain the other? So explanatory variable is going to be the number of years of study. Okay, so we're thinking that the more, classes you take, the better you're going to be doing on the verbal SAT. Okay? So the response would be the average verbal SAT score. So the following scatter plots show the same information, just using different scales. So figure A made it so that it starts at 0, 0. This does not use this space effectively. It's very hard to actually tell specifically what the distribution or the relationship between the two variables looks like. It's crowded. So figure B was used, so we changed the scale. So the X scale starts at 14, which is where our data starts, and then the Y scale starts at 425. So your calculator will automatically pick, the window that is useful for you. But when you're doing your own plots by hand, you also want to make sure that you're using a scale that uses the whole grid for your data. And so in scatter plots, it's okay to break the X and the Y axis. When we were talking about histograms and histograms and bar charts, we had to start our y-axis at 0 because we were looking at the heights of bars, so it distorted it if we didn't start at 0. But here, because we're looking at the relationship between two variables, it's not distorting it if we zoom in and we don't necessarily have the y-axis start at 0, 0. So it's okay to do that for scatter plots. So we can tell that definitely as your number of years of study increase, the average SAT score increases, but does this look linear? Does it look like it follows a linear pattern, like a line? It doesn't look linear, if you can tell. So this is going to curve and go up. Okay, so it's going to follow something more like exponential or something else, which is not linear. So if we tried to fit a line to it, it'd probably look something like this. So the line might do a good job down here when you're talking about 15 through 18. But after that, you're going to see the line is going to be very off when you're trying to fit a model to that. So the scatter plot for average verbal SAT score exhibits a fairly strong curve pattern, indicating there's a strong relationship between the two variables, but it's just not a linear relationship. So there's a very strong pattern, and we can fit a model to it. It's just not linear. So for chapter 3, we want the data to appear approximately linear. A curve pattern is a bit more complicated to analyze, and methods for summarizing nonlinear relationships we do in chapter 4, but we're actually going to hold off until second semester to discuss that. So we kind of skip over chapter 4, but those are all nonlinear, so exponential, and some other different types of graphs for that. When you're interpreting scatter plots in any graph of data, you want to look at the overall pattern. And for any striking deviations from that pattern, you can describe the overall pattern of a scatter plot by the direction, the form, and the strength. And we're going to describe each one of those in detail. So there's three things: the direction, the form, and the strength of the relationship. And then an important kind of deviation is an outlier. And in scatter plots, an outlier is an individual that falls outside the overall pattern of the relationship. So we'll talk about the rest in class. Thanks.